Imagine a spoonful of sugar dissolving in water, releasing a flavor so intense it can evoke emotions and memories, all thanks to a complex dance of chemistry and physics. This phenomenon, known as Maillard reaction, occurs when amino acids and reducing sugars interact, resulting in the formation of new flavor compounds. For centuries, cooks and chefs have been harnessing the power of this reaction to create dishes that not only tantalize the taste buds, but also evoke emotions and memories. From the golden brown crust of a perfectly baked loaf of bread to the caramelized sweetness of a well-cooked steak, the Maillard reaction is the unsung hero of cooking chemistry. But what exactly is happening at the molecular level to create these complex flavors and aromas? To understand this, let's dive into the world of chemistry and explore the science behind the Maillard reaction. It starts with the amino acids and reducing sugars present in the food we cook. These molecules are the building blocks of proteins and carbohydrates, and when heated, they undergo a series of chemical reactions that break and reform new bonds. As the amino acids and reducing sugars interact, they release volatile molecules that contribute to the aroma and flavor of the food. But that's not the strangest part. The Maillard reaction also involves the formation of new compounds with distinct flavors and aromas. These compounds can be sweet, savory, or even umami, adding depth and complexity to the dish. But wait, until you hear what comes next. The Maillard reaction is not just limited to cooking. It also plays a crucial role in the aging process of foods like cheese and wine. As these foods mature, the Maillard reaction continues to occur, breaking down complex molecules and releasing new flavors and aromas. This is why a fine wine or a well-aged cheese can have such a rich and complex flavor profile. The Maillard reaction is also responsible for the browning of foods, a process that occurs when the amino acids and reducing sugars react with oxygen. This browning can add a rich, caramel-like flavor to foods, but it can also be a sign of overcooking or spoilage. So, how can we harness the power of the Maillard reaction to create delicious and complex flavors in our cooking? First, we need to understand the role of temperature and time in the Maillard reaction. Higher temperatures and longer cooking times can result in a more intense Maillard reaction, but they can also lead to overcooking and the loss of nutrients. To achieve the perfect Maillard reaction, we need to find the sweet spot between temperature, time, and moisture. This is where the art of cooking meets the science of chemistry. By experimenting with different cooking techniques and ingredient combinations, we can unlock the full potential of the Maillard reaction and create dishes that are truly greater than the sum of their parts. And then something unexpected happened. The Maillard reaction started to play a crucial role in the preservation of food. As food cooked, the Maillard reaction helped to kill off bacteria and other microorganisms, preserving the food for longer periods. This is why cooking was such an important part of food preservation in the past. But what does this mean for us today? The Maillard reaction is still an essential part of cooking and food preservation, and understanding its science can help us to create healthier and more sustainable foods. For example, by using lower temperatures and shorter cooking times, we can reduce the formation of unhealthy compounds and preserve more nutrients. We can also use the Maillard reaction to create more complex and aromatic flavors without adding extra salt or sugar. The possibilities are endless, and the science of the Maillard reaction is just the beginning. Imagine a world where cooking is not just about following a recipe, but about harnessing the power of chemistry and physics to create dishes that are truly magical.
This is the world of cooking chemistry, where the boundaries between art and science blur and the possibilities are endless.
So, if you're ready to unlock the full potential of the Maillard reaction and take your cooking to the next level, then subscribe to our channel for more incredible stories like this. And if you have any questions or topics you'd like to explore, please leave a comment below and let's continue the conversation. Thanks for watching, and we'll see you in the next video. If you found this fascinating, subscribe for more incredible stories like this.